Hi, welcome back to my channel. Well, in this video, we'll try to learn how we can fit an artificial intelligence based neural network model in JASP utilizing a data set which I have used in one of my videos regarding the same algorithm, but that was made on RStudio. So we have a data set, it has got 60 observations, and we have got 7 columns 1, 2, 3, 4, 5, 6, and 7. And this yield is our target variable, and rest of the variables are considered as features or explanatory variables, because in the language of machine learning algorithms, we call all these variables explanatory variables as features. So in order to begin and proceed, let us click on this machine learning option here. So we have different categories: regression, classification, and clustering, which is an unsupervised learning type of an machine learning. Since our case is in our case our target variable is continuous, so we will click on this neural network within the category of regression. So we'll click on this neural network. So we'll be expecting output where number of hidden layers, number of nodes, and a validation set approach method. Will be having a training, validation, and test data set here. So first we'll choose our target variable, that is yield. Then after that we will put all these variables into this feature dialog box. Then within fraction of seconds, it will try to create an optimum neural network structure by choosing the optimum number of hidden layers and nodes. Since this is data set is very small, it has got only 60 number of observations. So by default, it has taken only one hidden layer, and within this hidden layer, it has taken 8 nodes, because this neural network structure is made up of 3 layers. One is input, output, hidden, and output layer. 38 observation out of 60 are treated as training, and rest 10 as validation and test. So let us start with the model performances. Let us see what selection criteria will be there. We have mean square, root mean square error, mean absolute error, and mean absolute percentage error. And the overall score is quite good, 0.93%. This is usually used to evaluate the performance of different algorithms, and these are actually the selection criteria. Let's just see the importance of each and every individual feature or explanatory variable in terms of mean dropout loss, which is found out to be maximum in this fruit length and minimum in case of fruit weight. Let us see the predictive performance by means of making a plot between observed and predicted values. Click on this predictive performance. So we'll be having a plot here, and these observations should be quite near to this red line. That is considered to be a good fit. Then we'll be having a mean squared plot with respect to the generations also here. With respect to this training and testing set, as the number of generations increased, we have a lower mean square error. Then activation function, by default it uses a sigmoid logistic sigmoid activation function, although we have a lot of activation functions also. Now let us try to create a network structure. Let us see, the number of hidden layers are only 8, and within that there are 8 nodes. Let's click on this. We'll be having a plot here, neural network structure. So here it will get displayed. So you can see the hidden layer is only 1, and we have 1, 2, 3, 4, 5, 6, 7, and 8 number of nodes within this. So we'll directly go to the training parameters, because we have a lot of options here. We can change the this activation function. It depends upon what kind of study you are doing. Either you are doing a classification or regression problem. Since a detailed video is already made in terms of RStudio, it is just to make you aware of what options we have. We don't need any hardcore coding to perform a neural network algorithm by means of JASP. Just few clicks, you can use any kind of structure here. Then we have a lot of options here. We can use backpropagation method also. Then we can change the network topology. Since in this case by default it has taken only one hidden layer, we can change it manually. So let us suppose in first layer we'll be having 4 number of nodes, and in second we'll keep it as 2 number of nodes. We will not increase up to 3, because a traditional neural network used to have a maximum number of 2 hidden layers, because if we are having 3 number of hidden layers, then we are moving to the deep learning process. So accordingly you can change here. You can also have an option of optimization here, where you can change the population size, the generation, the number of layers, the number of nodes in each layer, Then if we will click on this optimized also, so this structure will get changed, and same the dropout losses, and as far as this model perf matrices, this will also get changed. Again, it will do a certain kind of optimizing network topology, so all these things will get changed. So we have a lot of flexibility if we are interested to perform or fit this neural network algorithm by means of this. So we have a lot of option and flexibility while fitting this neural network algorithm in this JASP. So we don't need any kind of coding or any kind of functions for that. Just few clicks, we can fit any kind of structure we want, any kind of activation function we want, any kind of topology we want, any kind of algorithm we want, whether it is back propagation or something else, whether we want feed forward or backward method. We can change also our this data splitting or validation type of validation and training data set ratios. So a lot of flexibility is there. So this is highly recommended if someone is interested to perform this kind of an algorithm in a very quicker time. So a lot of options are available. Hope you will like this video. Thank you.